In the heart of building a RAG pipeline lies an often overlooked challenge. When your queries return documents in the right neighborhood, but not quite hitting the bullseye, it's tempting to tweak prompts or context endlessly. Yet, this approach hits a wall because the real issue isn't the prompt, it's how text is embedded. Most embedding models treat every input identically. Whether it's a query or a passage, both are processed through the same pipeline and mapped into the same vector space. Here, cosine similarity or dot product governs their comparison, a method that works well for structurally similar texts, like two product descriptions. However, this approach falters when dealing with inherently different structures. Consider a question such as, how do I handle database migrations versus a paragraph from a guide on migrations? The former is short and interrogative, lacking context, while the latter is dense and declarative. When both are forced through a symmetric encoder, expecting them to align in vector space is unrealistic. This mismatched encoding can lead to inaccurate similarity assessments. Asymmetric embedding architectures address this very issue by recognizing that queries and documents aren't structurally equivalent. They require different encoding paths to achieve meaningful similarity measurements. Zilliz highlights the importance of asymmetric setups for this precise reason, enabling more accurate alignment in vector space. A developer's insights into fixing RAG retrieval with asymmetric embeddings underscore a critical point. Standard embedding models are designed for text similarity within equivalent contexts, which is not what search typically involves. Treating queries as short documents leads to suboptimal performance, what some call the almost works syndrome of many RAG systems. This problem isn't unique to retrieval scenarios. We encountered it in our content pipeline's deduplication process. Our post embeddings were built from titles and roughly the first 500 characters, representing an opening vector rather than a full post representation. When comparing new drafts with existing posts based on these partial vectors, even substantial restatements scored misleadingly low similarity scores due to this mismatch. This illustrates a broader truth. What you embed fundamentally influences what you can compare meaningfully, whether it's the asymmetry between queries and documents or opening versus full-body content. Mismatched representations lead to deceptive similarity scores. Thankfully, modern APIs are beginning to address these challenges by incorporating task-specific parameters. For instance, Gemini's embedding models use a task-type parameter that distinguishes whether they're encoding a query or document, tailoring the process accordingly. Before diagnosing your model as the issue, ensure you're not overlooking such options. Moreover, when evaluating embedding models from providers like OpenAI, Voyage, and Cohere, it's crucial to recognize that the performance gap between these models is often less significant than differences in chunking strategies or retrieval logic. Asymmetric handling becomes a vital part of this logic, rather than an isolated factor. In essence, prioritize getting the encoding path right for queries versus documents before debating which model to adopt. By doing so, you set a solid foundation for effective retrieval systems and avoid the pitfalls of mismatched representations. This realization underscores why symmetric models often miss the point in achieving true text similarity. If this helped, like the video and subscribe for more.